In this video, we're going to study ellipses. Now, one of the ways you might hear an ellipse described is that it is a conic section. Okay, and so what we mean by a conic section is I take a cone, that's where the word conic comes from, and I take this cone and I make slices through it. Now, in the previous video that you probably watched, it was circles that we studied, and a circle is actually a conic section as well. So if I took a knife and sliced through, just straight across through the cone, I know that what I would get is a circle if I look down on the shape that was made after I made my slice. But suppose that I make a diagonal cut through my cone, then it's not going to make a circle. What it's going to make is an ellipse, or maybe you want to say kind of an oval, right? But that's really where an ellipse comes from. All right, so the way you define an ellipse is, first of all, each ellipse has two foci, and so these foci are at these particular points, and the ellipse is defined so that the sum of the distance from this focus to any particular point and the distance from the other focus to that same point is always the same. So a way that you can kind of imagine this is, suppose that on this blue dot I have a pencil, and that this is a string attached to the foci. And so if you just keep that string tight and trace out the shape that's made when you keep it tight, it'll make an ellipse. Okay. A nice practical example of an ellipse is the shape of an orbit of a planet around a sun. You could look at the orbit of, a star around another star even, or something like that. But the orbit of the planet around the sun is an ellipse, where you would think of the sun being at one of the foci, at a focus. Okay. Now, we kind of tend to think of orbits as circular, but that's because the two foci are really, really close together, which makes it look almost like a circle, but in reality it truly is an ellipse. All right, so what do the equations of ellipses look like? Well, you might suspect that they have kind of a similar form to that of a circle because of the similarity of the shape to the circle, and in fact it does. So I'm not going to go through the whole proof of this thing, but here, let me just kind of talk about where it comes from. If we know that the sum of these two distances we see is always going to be the same no matter where we're at, then we can make a statement about that. So what I'm going to do here is I'm going to talk about, first of all, the distance from F1 to this point. The distance from there to there, using the distance formula, is just going to be x minus negative c squared plus y minus 0 squared. Okay, because remember, the distance formula is just x minus the x value, y minus the y value, and square those, add them, take the square root. That's our distance formula. And then this distance here would be x minus c squared plus y minus 0 squared. And we know that this distance plus this distance is always the same. So what I'm going to do is I'm going to call this just equal to a constant, and for reasons that you find out if you go through the whole derivation, we're going to call it 2a, but the point is a is just constant. Okay? All right, so with that as the setup, I'm not going to go through the algebra, and I'll admit the algebra isn't totally clean. There's some kind of rough patches in it, but it's very doable. You don't have to have any special skills other than just being really careful with your algebra. And all I'll say is that after a lot of algebra, after a lot of work, what you end up with is an equation that looks like this. X squared over a squared plus y squared divided by a squared minus c squared is equal to 1. Okay, and so you notice that the letters and everything down here are the same ones I had up here, so I think you'll believe me that if I just rearrange these, I will eventually get here. All right, and then just to simplify it a little bit, this a squared minus c squared, I'm going to call that b squared. And so the general form of an ellipse that's centered at the origin is x squared over a squared plus y squared over b squared is equal to 1. All right. Now this is what it looks like in the case when the foci are on the x-axis. The a and the b switch if the foci are on the y-axis, and we'll see that on the next slide. All right. So here's kind of the two versions of an ellipse. So the one I just showed you, x squared over a squared plus y squared over b squared equals 1. Now the key here is that this a, its significance is that the vertices, which is the spot where what we call the major axis, the long axis, is crossing the x-axis, are negative a and a. Okay. Then we have the minor axis endpoints, so the shorter one here is 0, negative b, and 0b. And then when we look at this equation, let's also remember how the foci relate to the a and the b. So we know that c squared is equal to a squared minus b squared. And that's just coming from this observation, knowing that b squared is a squared minus c squared. And so if you just rearrange it, then you get that formula. Okay? And the foci are at negative c0 and c0, and so I can know where to put those. And then if the major axis is the y-axis, then what we're going to do is we're going to put the a under the y. So the a always corresponds to the major axis, and specifically what we call the vertices, right, where the major axis crosses the axis. So in that case, the vertices are 0, negative a, and 0a. The minor axis endpoints are negative b0 and b0. And still, though, c squared equals a squared minus b squared, but the foci are on the y-axis, so I put them in the y slot, of course, in the ordered pair. All right, so this is what we have to work with when we're looking at ellipses. All right, so let's do an example here. So we're given the ellipse x squared over 25 plus y squared over 16 is equal to 1. We're going to find the foci, the vertices, and the lengths of the major and minor axes. Okay, so how do you know which one's your a? Really simply, the bigger one. Okay, so here, since 25 is bigger than 16, I know that a squared is my 25, right? Going back to the idea that we know it's x squared over a squared plus y squared over b squared is equal to 1. All right, so a squared is equal to 25, so that means a must equal 5. So then the smaller one is b squared, 16, so that means b equals 4. So the a goes with the major axis, right? And so our vertices would be negative 5, 0, and 5, 0. And then we have, and so what of course that means is that I've got, if I make some little notches here, 1, 2, 3, 4, 5 in that direction, and 1, 2, 3, 4, 5 in this direction. Those are going to give me my vertices, right? And then we can also see that the length of the major axis right, is just going to be 10, of course, right? So negative 5 to 5 is a distance of 10. All right, so if my b is 4, then I know that I'm at the points 0, 4, and 0, negative 4. Those are where where the minor axis is, and so I'm going to go up 4 and then down 4. And of course that tells me that the length of the minor axis is 8. Okay. So we're in good shape. I can actually go ahead and start sketching the graph. No problem here. And as I'm doing this, I can kind of see that my tick marks were not spaced out quite well, so it kind of almost looks like the left side is a little bit longer than the right side. Of course, that's just my poor job of making my tick marks. But the one other piece I definitely want to do is put in the foci. I don't want to leave that out. And so remember that we have the formula that c squared is equal to a squared minus b squared. So that means c squared is equal to 25 minus 16, which is equal to 9. So that means my c is going to be equal to 3. So my foci are at negative 3, 0, and 3, 0. And so I can also show where those are at. All right, so now let's take a look at another one here. We want to graph this one, but it's in a little bit different form, right? So we know that we want to take x squared divided by a number and y squared divided by a number, and that'll tell us what our a squared and b squared are. And we don't have that yet, and we also want it equal to 1 on the right side, right? So 9x squared plus 2y squared equals 18. It's pretty easy to make a 1 on the right side if you just divide by 18, right, on both sides. So if you ever see that there's not a 1 on the right, then just divide by that number so you can get a 1 on the right. And what you'll get here is 9 over 18 is 2, right? So x squared over 2 plus y squared over 9. So understand in this case the bigger one is with the y. So that means that a squared is equal to 9. So a equals 3. So my vertices are going to be at 0, negative 3, and 0, 3. And then my b squared is equal to 2, so that means b is equal to the square root of 2. So I'll have the x-intercepts being the endpoints of my minor axis, and so that would be negative square root of 2, 0, and square root of 2, 0. And let's just, so that we know about where to put it, square root of 2 is about 1.41. So we know about where to put that. All right, so we can start making some tick marks here. I don't have to go too far out, right? So I'm going to kind of space these apart pretty well. So maybe this will be 1, 2, 3. 1, 2, 3. Okay. So we are at negative 3 and 3, and we are at negative 1.41. We'll put it right about there, and 1.41. And so that's enough to start getting a sketch of this thing. And again, I only do the dashed curves because it's a little easier for me to make a nice looking picture if I do that. Of course, we're just going to fill it in solid normally. All right, last part here is let's go ahead and put the foci in there, right? But again, just like in the last one, we know that c squared is equal to a squared minus b squared. And so c squared is equal to 9 minus 2, which is 7. So my c is equal to, square root of 7, which is approximately 2.6. And because my major axis is the y-axis, that means my foci are at 0, negative root 7, and at 0, root 7. But I know that's at about 2.6, and so 2.6, we'll put it right about there and there. Now what I want you to notice here is look how far out the foci are in this one. And this one's in a pretty elongated ellipse. And if I go to this one, it's a little bit less elongated and the foci are more toward the center. So what you'll find is that the closer the foci are to the center, the more circle-like it becomes. And then the further out they are, the more elongated the ellipse becomes. All right, so let's do one last example here. It says if the vertices of an ellipse are 0, 7, and 0, negative 7, and the foci are 0, 2, and 0, negative 2, find the equation of the ellipse and sketch its graph. Okay, and I can really do the graph sketching part of that right now. So vertices, right, are the major are the endpoints of the major axis. So I'm going to go ahead and put some tick marks in here. So there's 7, so I'll put a point there. And a point there. Okay, and I've been using a different color for the foci, so maybe I'll grab another one here. So the foci are 0, 2, and 0, negative 2. So right off the bat, based on what we were just talking about, notice how these foci are much closer to the center here relative to the vertices. And so we're kind of expecting this one to be a little more circle-like, I think. Okay, now let's focus on finding the equation right now. So because the vertices are on the y-axis, understand that this is going to be an ellipse of the form x squared over b squared plus y squared over a squared is equal to 1. And so we actually know a squared, right? So since we know that a is equal to 7, we know a squared is equal to 49. And so down here I can say x squared over something, I don't know, plus y squared over 49 is equal to 1. So if I can just find b squared, then I'll have my, not only will I have my equation, but I'll also know where to put my points on the x-axis, and then that will allow me to sketch the graph. Okay, but remember, we can find that easily. We know that c squared is equal to a squared minus b squared. And we know that a is 7, so a squared is 49. We know that c is 2, so that c squared is 4. So we know that 4 has to equal 49 minus b squared. All right, so minus 49 from both sides. And we get negative 45 equals negative b squared. So, of course, 45 equals b squared. So the square root of 45 is equal to b. Now, b squared is 45. That's enough for me to complete my formula, right? Because b squared is what goes under the x squared. So we're done with that part. So the only other part really to do is just to see, okay, approximately what is the square root of 45? And that's approximately 6.7. So on the graph here, I can go ahead and start making my tick marks. And so at 6.7 approximately is where I'll put my 2 points. And then I'll go ahead and graph from there. So and as I graph this, what you'll notice is that this one looks quite circular. And as we mentioned, that's because those foci are actually pretty close to the center. And in fact, right, negative 7 to 7 is the length of the major axis, length of the minor axis is negative 6.7 to 6.7. So that's really pretty close to being a circle.